example of tutorial question for the molecular diffusion in gases that we still haven't done it yet, but I think that it's okay. We just syllabus we should finish the syllabus first, and then perhaps during the face-to-face later on week 4 and upwards, we're gonna revisit that part, because that part eventually it will come out. Alright, untuk topik 1, 2, 3 ni dia akan keluar dalam kamu punya assignment 1 dan assessment. Okay, so hari ni saya nak fokus kepada molecular diffusion in liquid. Okay, so I hope that you can already watch the video. Okay, review the video, just dapatkan idea what is the molecular diffusion in liquid. Okay, so usually it's a very common phenomena occur in our daily life. Okay, kalau untuk unit of, okay, in a chemical plant, if the question asks you, okay, give the example of equipment which use the concept of molecular diffusion in liquid, so absolutely you can straight away answer it about the process of liquid extraction, gas absorption, distillation, right? So gas absorption is the one that we're going to learn after the MTA, and liquid extraction and distillation is the one that you're going to learn next semester in separation process. And then the answer for the molecular diffusion in liquid in a common daily life is the diffusion of salts in blood, oxygenation of river and lakes by air, and boleh carilah beberapa example yang lain. Okay, so you know that in terms of the packing, the atom or the molecule of liquid are packed much together, so it will create more resistant untuk diffusion process tu berlaku. Okay, kalau tengok dari segi subtopiknya, dia tak sebanyak molecular diffusion in gas, alright. They have equimolar counter diffusion, and the most famous one is the diffusion of molecule A through a non-diffusing beam. Okay, so the concept is similar with the gas. Cumanya sekarang ni instead of the medium is gas, right now the medium is the liquid. Alright, so if you can recall, if you ada yang part of student, maybe the belajar tentang liquid extraction, okay, during your diploma time. Alright, so kalau tengok later on, okay, dalam subjek liquid extraction, pula tak boleh ni. Okay, dalam liquid extraction process, alright, the topic to dalam CHE545 and 5, yes, CHE545, liquid extraction. Okay, so if you have, you know, a liquid coming from the top part, and this liquid having a molecule that we would like to separate, okay, contohnya the gas ammonia. Okay, so ammonia is dilute inside the water, so we're going to label the B as a water. So so we would like to recover this solid A, so that this first liquid, the water, is in contact with the another liquid, right, with the another liquid coming sama ada co-current atau counter current. So this is the another liquid. So that because of the different affinity, means that if the molecule A is much more soluble in the second liquid, and then the mass transfer will occur. Okay, so this component A will diffuse into the second liquid. Okay, and then you will get a more pure water. Okay, so this is the case of sekejap kelas. This is the case of a diffusion of A through non-diffusing B. So nampak dekat sini, hanya molekul A sahaja yang boleh, yang is impermeable, yang boleh dissolve inside the second liquid here. right? So the B, the molecule water is non-diffusing. Dia tak boleh nak penetrate masuk ke dalam the second solution. So that's what happens. That's why we can apply the concept of the liquid-liquid extraction. Kalau molecule water ni pun boleh dissolve kat dalam liquid-liquid extraction, then it's mean no point lah. Kan molecule A dengan B dua-dua boleh dissolve dekat dalam the second liquid. So the second liquid, it can be the organic solvent, acetone. Alright, so later on you're going to learn about that. Okay. Okay, contohnya macam ni lah. Kita nak asingkan propionic acid dalam air. Okay, so kita in contact kan water with the toluene. Okay, so propionic acid ni dia lebih have more affinity to toluene. So the mass transfer will occur. The diffusion of propionic acid will occur in a liquid phase, crossing from the water to the toluene. So berlakulah separation tersebut. Okay, what's the difference between this molecular diffusion kata dari segi equationnya? Okay, first kamu akan nampak ada satu pertambahan the new term which is the CEV. Okay, untuk molecular diffusion in liquid, alright, please take notes that you need to calculate the value of the CEV, concentration average, and here we have the SBM. So SBM ni lebih kurang sama je macam PBM lah kalau untuk gas P, and then kalau untuk untuk liquid itu kena X. But the new term is that you need to know how to calculate it. Calculate it is the CEV. So if you go through the example inside the video, lengthy, alright, but I think that if this question come out during your test, alright, it will be a bonus question for you because you just need to follow all the steps one by one. So nak buat macam mana nak follow the step means that you need to have a lot of exercises relating to this topic, subtopic, and it's quite lengthy, but it's very easy. Okay, so most of the student who've based on my experience, it seems like the student divided into two category. The one that can make it very very clear. The step is very clear from the beginning until the end, until they get the answer. And the some group just perhaps they don't do the exercises, just blur, and then you not get it right, kan? So dia tak ada yang macam yang tengah-tengah. Dia macam sama ada betul-betul boleh buat ataupun memang tak study, so memang tak boleh buat. Sebab memang dia punya calculation sebenarnya agak direct lah. Okay, cumanya agak panjang. So this is the thing is, this is the target. This is the value that we would like to calculate. But in order for us to solve for this NA, then you need to calculate the CAV and the SPM here. Usually the value of DAB, delta Z, and SA1, SA2 is given. Okay, SA1, SA2 ni pun kena kira lah daripada maklumat yang diberi. Okay, itu yang pertama untuk molecular diffusion in liquid. Okay, so kalau buat soalan, kalau keluar soalan phase dia dalam liquid, kita take notes that this CAV. Lepas tu kita nak kira diffusion coefficient for liquid kan. Kalau untuk gas kita ada correction factor DAB berkadar terus dengan T kuasa 1/75 bahagi pressure. Kalau untuk DAB for liquid, dia punya correction factor DAB berkadar terus dengan in parallel to the T over mu. So nampak kat sini kan, untuk gas perubahan temperature dengan pressure memainkan peranan dekat nilai DAB, influence the value of the DAB. But for the liquid, the temperature and the viscosity, okay, will influence the value of the DAB. Okay, so Wilkie-Chang, we have here Wilkie-Chang correlation and the Stokes-Einstein correlation. So to use this equation in order for you to get the DAB, so please take note to follow the, what we call it, the unit. Okay, so we would like to have the DAB in the unit of meter square per second. So you just follow, contohnya macam mm ni apa kan. So kena faham kat sini, ada di label sebagai MB, ada di label sebagai mu B, and ada di label sebagai VA. So first, kamu kena tahu which one is component A, which one is component B. Alright. So barulah kamu biasanya kalau komponen B ni adalah solvent. So biasanya macam ni lah yang water, methanol, ethanol. Kalau solute ni biasanya apa macam ammonia. Alright. The solute A that we would like to recover. So you look up into the notation here. So kalau BD maksudnya dia bukanlah molecular weight of the solute, but it's the molecular weight of the solvent. So if the ammonia is dilute inside the water, and then the MB here is water, which is 18.02 kilogram over kilogram mole. Okay, and then ni silap kan, ni bukannya M, dia adalah mu. So label dia pun adalah komponen B. Mu B means that mu, you know, that's a viscosity. Not so it's a refer to the viscosity of the solvent or the medium. But here we have the V. V is a A. So A here means that refer to the solute A. What is it? The propane acid, the ammonia. So the VA here is the solute molar volume at the boiling point. So you need to refer to the table 632 dekat dalam dekat dalam textbook. Okay, refer table 632. So kalau kamu tengok table 632 sekarang, okay, table 631 discuss list down table 631 is list down the diffusion coefficient for dilute liquid solution. Okay, untuk common phenomena involving molecular diffusion in liquid. Contohnya tengok sini, ammonia dissolve dalam water, berapa DAB dia, okay. Carbon dioxide dalam water, berapa DAB dia, acetic acid, acetone. So bila nak dapatkan nilai DAB ni, first soalan dia akan bagi. But let's say that the soalan is not given. Okay, you need to look up if there is a common equation, common process, then you can take a look inside the table 631. Kalau tak ada juga dekat dalam table 631 ni, ataupun kalau ada tapi dia punya temperature berbeza, tak boleh guna kan, kamu kena guna equation sama ada Wilkie-Chang atau Stokes-Einstein here. Okay, so sekejap. Okay, table 632 untuk nak guna Wilkie-Chang ni ataupun Stokes-Einstein, kita ada nilai VA tu kan, it stand for a solute molar volume. Okay, sebelum tu kena tahulah temperature must be in Kelvin, the molecular weight must be in a kilogram over kilogram mole, the viscosity must be either in a Pascal dot second or kilogram over m.s. You had a textbook with you, you refer to the table 632 sekarang. Tengok table 632. Okay, dia bagi material dia dalam bentuk atom, right? Atomic, carbon, hydrogen, oxygen, nitrogen, bromine, right? So that the atomic volume there, alright, so means that let's say that you're talking about the solute ammonia, then you need to know what is the chemical structure of the ammonia. Ammonia NH3. So 1 darab N tambah 3 darab H. Alright. Okay, so you follow this one and this one. So prediction, I hope you already done it, alright. And then another thing is that dalam molecular diffusion in liquid, kita ada satu solution solvent yang biasa, water, satu lagi contohnya water, satu lagi adalah when it's involved the electrolyte solution. Contohnya macam garam lah yang paling common, NaCl. Okay, when you dissolve the NaCl inside the water, dia ada ion, right? Na plus, Cl minus. So how you would like to calculate it? Okay, using this Nernst-Haskell equation, ataupun ada dia punya correction factor here. Okay, kita tak perasan dalam note ni, dia kata apa? To correct the DAB, so nampak tak dia ada simbol degree kat sini? So kalau ada simbol degree kat sini, we know automatically that we are talking about the molecular diffusion in liquid electrolyte solution. Okay, So this is the equation for the correction factor untuk electrolyte solution. Okay. Kalau untuk yang biasa, just simple je DAB. Okay, berkala terus dengan T over mu. Kalau untuk electrolyte, here it is, DAB, nu ni maksudnya kita nak carilah. And then you need to use the value of DAB at 35 degrees Celsius. Okay, 35 degrees Celsius as a reference. And then the temperature here in Kelvin, this the temperature that you like to look into. Kan, nak dapatkan DAB pada suhu yang baru 50. So masukkanlah suhu 50, 35 ni kat sisi Kelvin. And kena cari viscosity of water dalam unit CP dekat new temperature. Catat the viscosity of water. So memang nama nampak pun W, so X constant lah. Water, okay, dalam unit CP. Okay, viscosity dalam unit CP dekat temperature yang baru ni. Contohnya kalau 35 tambah 273. So all these things will be listed out in the appendix. So with this kind of question, if it's coming out, means that you need to know what does it stand for. Okay, all this notation. Alright. Okay, then saya pergi laju sebab if you doesn't get it, means that you can revisit. Okay, watch the video because my we doesn't have a class this Friday. Saya cuti, alright. Hari Khamis cuti, so kan, alright. So what we're gonna do today is that we just do some exercises. Okay, maybe I shouldn't take your time so long untuk buat exercises, tak banyak untuk molecular diffusion in liquid. Okay, so kita start dengan problem 631. Okay, kau tengok dekat textbook. Okay, for those who doesn't have it, perhaps you can ask your friends to capture the question and put it inside the group. Tajuk dia diffusion of A through stagnant B. Okay, dalam ni senang akan dibagi apa benda tajuknya, so kamu tahu. We are talking about the solid HCl. Okay, boleh jumpa tak soalannya? The solid HCl, hasil hydrochloric, dilute dekat dalam water. Now we are dealing with the problem 631. Diffusion of... Kau dapat ke soalannya? Ada soalannya? Somebody answer me?
Okay.
Diffusion of HCl in water B. Okay. So maklumat dia apa yang dibagi? You read the question and then we extract the information, kan? So sekarang ni sebab senang lah, tajuk dia memang dibagi apa? Diffusion of A through stagnant B. So you know what type of equation kita nak guna, kan? Yang ada CEV dengan SVM tu. Okay, so the thing is right now, you take out as much as information from the question. Okay. Do you get the question? Sebelum tu, sebelum saya mula.
Yes, betul. Ada.
Okay. Okay, perhaps you can respond to me dekat bahagian apa? Chat box ni. Okay. Chat box, maybe someone can just write down the apa? Maklumat apa? The solid head is diffusing through a team of water 2 mm thickness. So you know that the Z is equal to 2 mm. Actually equal to Z is equal to, ada yang lupa nak off ni ke? And that's the value of Z. And then the concentration of HCl at 0.1 at one boundary of the film is okay. So it's easy here because dalam soalan ni dia memang ialah we just want you to get familiar how to solve it, how to solve it. Dia dah siap bagi dah 0.1 berapa, 0.2 berapa kan. So maksudnya sekarang ni senang lah. Kalau biasanya dalam soalan dalam MTA ke apa, tak adalah bagi mana 1.1, mana 1.2. Kamu yang bila baca soalan, kamu yang kena tentukan sendiri. Apakah solute A, apakah solvent B, okay, and then which one is 0.1, which one is 0.2, so that kamu tak keliru lah untuk labelkan the value of the XA1 and also the row A1. Okay, so dalam case ni senang dia cakap apa, CA1 okay, even the row 1 CA2 is also given here. CA1, CA2 is given, row 1 and row 2 is given, the DAB is also given. Density at DAB is equal to jarak 10 kuasa okay, kan, this is the information being given to us. Okay, so you know, first we write down the equation that we're going to use. Kan? The NA sama dengan alright. So this is the things, okay. So if you look up into the notes and we follow the step from the notes step by step, apa dia? Okay, so we need to assume, okay, because given to you the the mass in a percent, right? So means that you need to make an assumption, right? We assume that it is a 100 kilogram solution. Solution ni maksudnya berat liquid tu lah. Kan, solvent tambah solute dia akan jadi solution. So kenapa 100 kilogram? Because it will be easy for us, because kalau 12% here, CA1 12%. So kalau 12 darab dengan 12% dengan 100 akan jadi 12 kilogram. Okay, so first step is that we want to calculate the value of SE1. So you know that it's actually macam mana nak kira tu. Alright, it's actually 12 kilogram because 12 here, 12% darab dengan 100 akan jadi 12 kilogram, and then you divide it by the molecular weight of the apa HCl. Okay, so sekarang ni kalau molecular weight HCl supposed to be okay, first kena cari dulu molecular weight. Okay, if it's not given, kalau dalam assignment kalau tak dibagi pun, you just simply can Google je lah kan berapa molecular weight untuk A. So sekarang A adalah HCl, should be 36.7. B adalah water, lebih kurang 18 lah. Okay, 12 kilogram bahagi dengan 36.7. Okay, kira. Find SE1. Sekarang kita nak start cari find SE1. Okay, we divided the kilogram with the molecular weight so that we can get the unit of kilogram mole. So divided by 12 bahagi dengan 36.47 tambah. So we have 100 kilogram solution. So kalau 12 kilogram adalah HCl, the remaining 88 kilogram adalah water. Kan? So this 88 you divide it by the 18.02. So the value of SE1 that you get is berapa? Cuba kira. Lepas tu nanti kita dapatkan SB1 1 minus SE1. Lepas tu kira SE2 pula. SE2 so berapa tadi? Okay, someone boleh type berapa jawapan kamu untuk nilai SA1 dengan SB1? Kosong 6312. Okay, good, betul. Okay, SA1 0.0632. So kamu akan dapat SB1 sama dengan so maksud SB1 ni maksudnya dekat point 1 kan, dekat point 1 ada molekul A dengan molekul B. So bila kita tambah SA1 dengan SB1 ni dia akan sama dengan 1. Okay. Okay, so saya tolak je lah. Okay. Someone, Nur Aina Syafina, thank you so much. So kita buat SA2 pula. SA2 berapa tadi dia punya berat dia? Berapa persen? 2%, right. 2%. Dekat point 2 dia punya adalah 2%. So 2 darab 100 sama dengan 2. 2 ke 6? Sebab ni 6 ya Allah. Silap tak siapa mau tegur saya. CA2 ni silap Update. CA2 sama dengan 6%. Saya silap type. Okay, so kira 6. Kira 6 kilogram bahagi repeat je. 6 bahagi 36.47. Lepas tu buatlah 6 bahagi 36.47 tambah 94 bahagi 18.02. Okay, so dapat solve as A2 and dapat value SB2. SB2 0.9694. Okay, correct. Okay, so sekarang ni saya nak kamu kira. Okay, so yang kawan yang lain tu catatlah berapa nilai kat sini. Okay, untuk kamu check dengan jawapan kamu. Okay, so sekarang ni kita pergi step yang kedua, nak kira SBM. SBM sama dengan SB2 minus SB1. Okay, so SBM. Okay, someone kira. Okay, good. 0.9530. Okay, so maksudnya masukkan je nilai SB1, SB2 yang kamu dah kira. Okay, so kamu akan dapat, tekan kalkulator betul-betul dan you will get the value of 0.95306. Okay, so we already done with the two step here. Okay, step 1 and step number 2. Dan we go to, so tengok dekat sini kita kiranya kita dah ada nilai apa? SA1, SA2, SBM, delta Z and the DAB. So sekarang ni of course kita nak kira nilai CAV. So CAV, kalau tengok rumus CAV dia ada apa? CAV is equal to rho 1 over M1 plus rho 2 over M2 bahagi 2. So M1 here is a molecular weight at point 1. So you know, right, we have 2 points here. The diffusion occur from point 1 to point 2. So at point 1, we have a component A and B at different composition of different concentration. And at point 2, we have a different composition of A and B. So of course, the composition or the concentration of this component A and B will influence the molecular weight. Alright, so molecular weight M1 here refer to the molecular weight at point 1 and M2 here refer to the molecular weight at point 2. So how to calculate the M1? So M1 molecular weight is defined as a berat mass bahagi dengan kilogram mole. Alright, so in order for us to calculate the M1, then the mass here we assume that it's a 100 kilogram solution, kan? Just now we assume that it is a 100 kilogram. So bahagian bawah ni, the denominator part is in a kilogram mole. So how do you want to get a kilogram mole? Okay, means that here 12, we still remember 12 kilogram of HCl. If you divide it by the 36.7 kilogram over kilogram mole. Okay, so you can see here that it's cancelled out. So the unit is right now in kilogram mole. Okay, but you have two components A and B, right? So this part is the HCl. So what about the water? Water berapa berat dia dekat dengan 0.1 ni? 100 tolak 12, 88. So sama juga lah, 88 kita bahagi dengan 18.02. Okay, so berapa nilai M1 kamu? 19.18 kilogram. Okay, good. Aina, you put the unit as well. Kilogram over kilogram mole. Okay. 19.18 kilogram per kilogram mole. Okay, now proceed with the M2. Berapa? Berat masih lagi 100 kilogram, yang berubah dekat bahagian bawah sahaja. Ikut berat komponen A dengan B. So, berapa M2? Kita letak di sini pula. (18.58 kilogram over kilogram mole). Okay, Untuk M2 jawapan dia 18.58 kilogram per kilogram mole. What you're going to do is that you just replace 12 ni dengan 6 kan. 88 ni tolak 100 tolak 6, so 94. Okay, now we go to the step number 4. The CAV. Rho 1 over M1 plus Rho 2 over M2. So nilai Rho 1 dengan Rho 2 tu kamu dapat daripada mana? Dibagi kan dekat dalam soalan. Cuba lihat soalan tu. Nilai CAV and A ni kira balik, masukkan balik. Ni unit ni kilogram mole over meter cubic. Okay. Step number 4 and step number 5. What's your CAV value? 55.4. Okay, 55.4. Okay, betul lah. CAV value is 55 point apa? 4 lah 365. Okay, so NA ni DAB dia berapa? 2.5 10 10 kuasa negatif 9 meter square per second. You multiply with the 554 kilogram mole over meter cubic darab dengan SE1 minus SE2 berapa tadi value? Okay, kamu istilah value SE1 minus SE2 here. So delta Z berapa tadi? 2 darab 10 kuasa negatif 3 meter kan. So darab dengan SBM tadi berapa nilai dia? 0.953. So nampak kat sini unit cancel kan? Meter square here become meter kilogram over meter square dot second. Okay. So the answer is given inside the textbook, right? Jawapannya dibagi 2.372 darab 10 kuasa negatif 6. So be careful bila mana kamu involve dalam solution soalan macam ni. Okay, even you get contohnya 2.372 darab 10 kuasa negatif 3. Okay, so 10 kuasa negatif 6. Okay, your answer is still wrong. Okay, so kamu mungkin akan dapat cara kerja, markah dekat unit, but the value itself, the answer is wrong, even that you get the 2.372 tu. Okay, pastikan dapat final NA ni. Alright, so we take 5 first. You try to look back again from the step 1 until step 5 here. Okay, kita sambung balik pukul 8.52. Okay, semua yang kalau dah calculate tu boleh share